Hi guys, this is the second video on the carbon cycle, and in this video we will be learning about the movement of carbon between stores, understanding the effects of the changing carbon budget, and answering an exam-style question.
In the previous video we learnt about the different stores of carbon as shown here in this diagram, and just to give a recap, we had the hydrosphere, which included the oceans, the lithosphere, which was the crust and the upper mantle of the earth, the biosphere, which was our living factors, such as plants and animals, and then lastly our atmosphere as our last store. So now we're going to look at how carbon has moved between these stores, starting off by giving a brief overview to the different types of movements we have. So we have movement through human processes, such as the burning of fossil fuels. We have the geological component, which includes things like volcanoes, and also the movement of rocks and the rock cycle, photosynthesis, which is to do with plants. We have other biomass processes such as respiration and decomposition, oceanic carbon pumps, combustion and volcanic activity, and we're going to go through these in greater detail now. So don't worry if you don't understand what these are now, I'm going to go over them all. So before I go into these different types of movements, it's good to understand what are carbon sinks and carbon stores. And a carbon sink is a store that takes in more carbon than it releases, and the opposite is a carbon store which releases more carbon than it takes in. So for example, if I draw a box here as our carbon stores, the carbon store is going to be releasing more than it takes in, shown by the fatter arrow, and the opposite for a carbon sink, which is taking in more than it's releasing. So firstly, we're going to look at the geological component of the movement of carbon, and this is to do with the rock cycle. So the rock cycle involves processes like the weathering of rock, which is the breakdown of rock. We have the burial of rock, subduction, and this is what's happening at plate boundaries, such as destructive plate boundaries, where, for example, we have a tectonic plate being subducted underneath another plate, and when it's subducted into the mantle, which is beneath the crust, it melts and becomes part of the mantle. So that's what subduction is. And then also at tectonic boundaries, we also have volcanic activity, where the mantle is coming up and lava is being released onto the Earth's surface through volcanic activity. So this is how carbon is moving back from the mantle into or onto the Earth's surface. And it's also released as gases because volcanoes also emit gases such as CO2. So it's also releasing CO2 back from the mantle into the atmosphere. Another part of the geological component of carbon movement is the formation of limestone. And this is through the process of carbon dioxide and water forming to form carbonic acid. And this carbonic acid then reacts to form calcium carbonate, also known as limestone. And this is a type of sedimentary rock that contains carbon, as shown here. And then, as I was referring to before, through the subduction of plates at plate boundaries and where we have volcanic activity, this limestone and sedimentary rock that's been subducted is melted and then is released in volcanic activity. It comes back up to the surface again, and CO2 is then released back into the atmosphere through volcanic activity. So that's just the process in greater detail of how carbon is cycled through the geological component. Through reacting to form limestone, the limestone is then melted and then comes back up to the surface through volcanic eruptions, and CO2 is released back into the atmosphere in clouds from volcanoes. The next movement we have is through three interrelated processes, which are photosynthesis, respiration, and decomposition. So photosynthesis is the process that plants do to make their food. And this food is normally a carbohydrate, or otherwise known as glucose. This is because plants don't eat other things. They're called autotrophs. So they make their own food using carbon dioxide, water and sunlight. And this process releases oxygen as well as forming glucose, which is a sugar which the plant uses to grow. And a similar process is respiration. And carbon is moved in this because animals and plants do respiration to produce or release energy from carbohydrates, such as glucose. And here it's combined with oxygen, and then when this reacts together, we get a release of energy, water, and also carbon dioxide. So here, carbon dioxide is being produced, and during photosynthesis, it is being consumed. So they're almost like opposite processes of each other. So that is carbon movement here, but we also get carbon movement in decomposition, and this is when organic matter such as dead plants and animals are decomposed by decomposers such as worms to form more stable forms of carbon that are put back into the soil of the earth. And this recycles the carbon back into the soil, as said here, by decomposers such as little organisms like worms. The next movement we have is through oceanic carbon pumps, and this is to do with oceanic circulation, represented by these arrows on this map here. And the orange arrows represent the transfer of kind of warmer surface currents in the ocean, whilst the blue arrows are those which are colder currents, which travel at the deep depths of the ocean. And carbon is transported through these ocean conveyor belts because as this hot water circulates towards the poles, it cools when it's in contact with the ice, and this causes the water to cool, and because cooler water is more dense, it sinks to the bottom. So here, carbon dioxide is being transferred from the warmer surface currents to the deeper, colder currents until they travel back round towards the equator and bound by the Pacific, where they rise again and they warm up. So this is a transfer of carbon from the warmer layers to the lower, cooler layers of the ocean. Then we have combustion, and the process of combustion releases carbon in the form of carbon dioxide from organic material when it is burned, and this process also releases water and energy. So, for example, this is the combustion of fossil fuels, which are burnt, for example, in cars, petrol, to release energy, and this releases carbon dioxide. We also have biomass combustion, which is the burning of things like wood and plants. And this is normally human-induced, but we can also get natural fires, and here the carbon is being released from being stored within the wood back into the atmosphere when the wood is burnt. As I mentioned before, carbon dioxide is also released back into the atmosphere through volcanic eruptions, and this is because CO2 is stored in the mantle of the Earth, and at volcanic eruptions, the magma within the mantle is rising up through the crust, and CO2 is emitted by volcanoes back into the atmosphere. So now I'm going to give you a few human activities which are causing the movement of carbon. These include hydrocarbon extraction. So this is extracting fossil fuels such as coal, oil and gas from their stores deep in the lithosphere and using them for combustion, the consumption of fuels for energy, and this is releasing the carbon stored within the fossil fuels back into the atmosphere as carbon dioxide. Also, farming practices are big emitters of carbon dioxide and methane, especially the beef industry, as when cows digest, they produce a lot of methane, which is CH4. As you can see, it's a carbon compound, and this has serious implications for the greenhouse gas effect, which we'll look at in the next video. Also, deforestation. A lot of the wood from deforestation is burnt in fires to clear the land, but also deforestation means that less carbon dioxide can be absorbed from the atmosphere by the trees during photosynthesis. So this type of human activity has major impacts for the carbon cycle. And also urban growth. where we get the development of cities, we're obviously having greater amounts of transport that require fossil fuels. So we get a greater consumption of fossil fuels overall for electricity and things like that. So human activity has profound impacts on the carbon cycle as it changes the route of carbon. And we also have a type of human process called carbon sequestration. And this is where carbon dioxide is captured from the atmosphere and put into long-term storage. And this is to stop it reaching the atmosphere because it has very damaging effects. And this is to prevent the greenhouse gas effect or global warming. And carbon, in this case, can be stored as carbon dioxide in what's called geological sequestration or terrestrial sequestration. So geological sequestration is storing this carbon dioxide down deep within rocks, and terrestrial is trying to store it within trees and plants. As we just learned, human activity was having major impacts on the carbon cycle and was releasing a lot of carbon dioxide into the atmosphere, causing global warming due to the greenhouse effect. And so now we're going to look at the effects of this changing carbon budget. And firstly, in relation to the land, the impacts of the changing carbon budget are currently unclear because it hasn't been studied for long enough. However, there is distinct impacts taking place on the ocean currently which are very visible, the first one being sea level rise, and this is because of the melting of sea ice as well as other factors which are causing sea levels to rise. Also attributed to melting sea ice is that normally sea ice reflects a lot of solar radiation back into space, which helps to cool the planet. However, with less sea ice, there's obviously less reflection, so this also acts to increase global warming. But also, sea level rise can be caused by thermal expansion. And this is when the water is heating up, and water expands when it's heated. So the sea levels are actually increasing via volume, as well as the amount of water being in the seas. This release of sea ice, the fresh water trapped in sea ice, is also reducing the salinity of the oceans. Also, the warming of the oceans is allowing phytoplankton to breed. This makes the water almost appear cloudy, and plants that live within seas and oceans in the surface level require photosynthesis to survive, and therefore sunlight penetrating the water. However, if the water is kind of cloudy because of the phytoplankton, sunlight can't get to the plants and therefore photosynthesis can't take place, and it causes the plants to die. Also, this changing carbon budget is causing ocean acidification. Now, oceans are very slightly alkaline, and through the removal of carbonate ions from the oceans, this is making the oceans more acidic. And this has really significant impacts for coral, because coral actually uses carbonate ions to form its shells. And other animals as well as coral do this as well. And this is causing massive coral reefs to die out, shown here. And this is a picture of dead coral. Now, dead coral is white in colour, whereas a live coral has very vibrant colours. To talk about sea level rise in a bit more detail, this photo here shows an example of a beach and indicates where the water level will be by 2030 and 2050. And this is really significant. And as I mentioned before, sea level rise is both due to the melting of ice, which increases the volume of water, and also through thermal expansion, through the heating up of the oceans, causing the water to expand. So the impact on the atmosphere is that with an increased amount of carbon dioxide in the atmosphere, carbon dioxide is a greenhouse gas and it controls the Earth's temperature. And carbon dioxide only accounts for 0.04% of the gases in the atmosphere, but it's only this tiny amount that keeps the Earth as warm as it is today. And with an even tinier amount added onto this, this can cause significant warming effects, which will potentially damage the Earth's ecosystems and have other serious impacts. And the reason this happens is due to radiative forcing. And radiative forcing is the balance between of solar radiation coming into and heating the Earth and its atmosphere. So, as you may know, the Earth receives its heat from the sun. However, CO2 and other greenhouse gases can act as an insulating kind of blanket around the Earth, which keeps the Earth warmer. So with more CO2, it's almost as if we have a bigger blanket, so the Earth is going to warm up even more. And this is because this said kind of blanket is absorbing the heat. So if I draw an example of the Earth here, the increasing levels of CO2 and other greenhouse gases would cause more solar radiation from the sun to be absorbed than is reflected back into space, whilst if the Earth were to be cooling, we would have more solar radiation being reflected rather than being absorbed. So this is what radiative forcing is. It's this balance between absorption and reflection, and radiative balance would be where we had an equal amount of absorption and reflection. However, the global warming is occurring because we have too much being absorbed and too little reflected back. And this is because carbon dioxide, the molecule itself, absorbs solar radiation rather than reflecting it, and this is warming up the Earth. So to finish off this section on the carbon cycle, we're going to answer some exam-style questions. The first is a multiple choice question, which asks, which is a store of carbon? A, photosynthesis, B, biomass, C, respiration, or D, decomposition. And the answer is B, because B is a store of biomass, whilst these others are processes of carbon movement. The next question we're going to look at is a longer 6 marks question, which asks, the figure below shows the changing amounts of carbon dioxide production by source. Using the figure, analyse the changes shown. So this is the figure we have, and it shows changing amounts of carbon dioxide by source between 1900 and just beyond the year 2000. And it shows it for coal, oil, gas, flaring, and cement. And it's measured in carbon dioxide emissions in gigatons of carbon per year, and the graph is cumulative. So this point here is the cumulative amount of carbon emissions for the year roughly of 2010. So as we can see, back in 1900, the only emissions were coming from coal. However, as time has gone on, as we get to 1950, we start seeing the emissions coming from oil, gas, flaring, and cement. But over time, coal tends to be the main source of emissions, with oil kind of coming into second place, being the second biggest emitter, then gas, then flaring, and then cement. However, as we can see, there is a dip here at about the 1970s, 1980s, so it will be good to comment on this little fluctuation we have here, as it is the only anomaly we have in the trends that we can see in this graph, which is that the emissions from carbon are increasing as time goes on. So now we're going to answer the question. So in a previous video, I mentioned that a good way to answer a question using data is to use the format of OPAD, which means overall, pattern, place, anomalies, and data. So we need to include all of these factors. So beginning of this question, we're going to state the overall trends. So I said, overall, the graph shows a steepening increase in carbon dioxide production from 1900 onwards. Coal remains the largest source of CO2 emissions across the last century, whilst oil and gas emissions have significantly increased since 1950. Emissions from cement and flaring have seen a minimal increase. So this is giving the overall trends for the different types of productions by source. Now I'm going to specifically comment on some of the patterns and include some of the data. So I've said CO2 production dramatically increased from around 1.5 gigatons of carbon per year in 1950 to 10 gigatons of carbon per year in 2010. So yeah, I'm using data really specifically. This is something you really need to do. This could be linked to the increase in global population and thus energy demand following World War I. So here I've taken the data and I've analysed it. And then I'm going to talk about an anomaly, which I mentioned when we looked at the graph was that little dip that we saw. So I've said an anomaly is the decrease in emissions across all sources in the 1980s. This could be the result of a disruption to the supply of fossil fuel sources, which therefore sparked a sharp decrease in consumption. So yet again, I've provided my anomaly and then I've given a bit of analysis to it as well.
Hi guys, I hope you enjoyed the video. If you're looking for an amazing A-level geography resource, join me today in my series of engaging bite-sized video tutorials. See you soon, and together let's make A-level geography a walk in the park.